Assalamualaikum and good day to everyone. This is our first class for microprocessor to EEE320. Before this, we have all of you have taken the microprocessor 1 EEE226, which during that time we are focusing on Intel microprocessor, which um, the different it is a different architecture from the one that we are going to cover the whole semester, this semester. Intel microprocessor actually based on a CIS. Actually, there are two kind of architecture for the microprocessor. We have CIS and RISC, where CIS stand for complex instruction set computing, while RISC it is reduced instruction set computing. So there are a difference between both of these in terms of architecture. Nevertheless, they have their own advantages and disadvantages. Well, I'm not going to discuss in detail regarding CIS and RISC, where I'm going to give you a assignment later on. Today, I would like to introduce you with the ARM processor. Okay, we are going to look on history of the ARM and what is ARM stand for and when it is begins and the basic architecture of the ARM before we go into detail for the next chapter. Okay. The ARM currently ARM stand for Advanced RISC Machine. RISC, as I mentioned before, it is a reduced instruction set computing machine. Previously, it's been known as Econ. This machine, where Econ is the company that uh, invent the ARM processor. Okay, founded in November 1990, where it is in the beginning, it is from the Econ computers, called, where actually Econ computers actually is located in the Cambridge, United Kingdom, where the processor design center in the Cambridge, Austin, and Sophie Antipolis. Where also in the headquarters also they have a sales support, engineering office which is all over the world. Best known for its range of RISC processor core design. Econ also they have other kind of product, for example, fabric IP, software tools, for example, for debugging models, sales library, which used to help partners develop and ship ARM processor system on chips. As you know that ARM does not manufacture silicon, it didn't make the silicon like Intel, where all the processor is being uh, developed by Intel itself, but not for ARM. ARM does not manufacture the silicon, the hardware, the microprocessor itself. Okay, this is the ARM processor located all over the world. We have all over the world. Where in the Southeast Asia we have in Singapore. Why actually we need ARM? As I mentioned to you that we have two kind of architecture where we have this and this. ARM is this kind of architecture for multi and both of them actually have their own advantages and disadvantages. But why we need to use ARM? Okay, the main one of the main reason that why we need to use ARM is because it is a low power consumption kind of microprocessor. Since it use less transistor in the ARM processor, so it's going to use a low power consumption. It is a fast execution per watt. Why we mean by fast execution? Since each of the instruction in the ARM only require one cycle to execute compared to six. Six, where some of the instruction is we can have up to 15 byte, while ARM the instruction is fixed only 32 bit. So that's why we consider it is a fast execution per watt. So also relate to the using only a low power consumption. Inexpensive also relate because of the less transistor being used in the processor and variety of core offering. Since you have a lot of core which are suitable for particular application. It offers a lot of core which we can select for a particular application. And marketing as we know that it is all over the world, it's much easier. And as we know that since the ARM is not the one that manufacture the silicon, so all other partners which involved with the ARM, which use the ARM license, ARM processor license, so the family of ARM getting bigger, and it all scattered all over the world. Uh, and the reason, this all listed reason, make it in 2005, which 98% of mobile phone use at least one ARM processor core on their motherboard, according to the research from the analysis of the everything. This is the reason where, if we look back, actually there are no other processor which can compete with the ARM in terms of being used in the mobile phone. Okay, this is just the overview. Okay, ARM, the architecture for the digital world. ARM is a physical hardware design. Okay, it is a physical hardware design where you can have a physical hardware and also considered as an intellectual property company. ARM license its cores out and other companies make the processor based on it. means that you can use my design, but you need to build up your component, your hardware by your own. You only purchase the license for each of for the company that you want to use the ARM. Okay, ARM also provide the tool change and debugging tools for its core. Okay, if you have purchased the license, then you have the tools, software tools which can debug by ARMS. You can use it ARMS tools. Okay, actually there are a lot of companies that use. Maybe just some of it is limited to the time I'm taking it. Most probably we have more than this. Okay, this is the basic overview of the ARM processor. If you look here from the block diagram, this is the one that been designed by the ARM. Whereas, for example, the system, the analog, the memory, the serial interface, and other peripheral are designed by the chip manufacturer, the one who want to develop the physical processor. So also ARM is the one that only provide the license for the ARM core, whereas the rest of the component inside the processor is designed by particular by certain by the one that purchased the ARM core. Okay, okay, Econ Computer Group actually the first the first company that introduced the RISC processor, is reduced instruction set computing, okay, being used by the BBC microcomputer in the beginning, which in 1986, okay, this is the first processor by Icon Computer Group. Okay, ARM1 second processor for the BBC Micro. Okay, this is also which in the beginning they are more focused on developing the computer. You know, during that time, mobile phone is not really popular. But the computer is going faster during that time. Okay, ARM Limited founded in 1980. ARM Econ Computer Apple BSI Technology, where nowadays being called NSP. Okay, ARM 6, which released in 1981 on the ARM architecture version 6. Actually, this is the beginning of using the processor inside the mobile phone. Okay, and it being used by the Apple in the EDA. Yeah, this is the look inside the PDA. Really use the ARM processor. And then we have in 1996 the ARM 7, which being used widely. Okay, and also being used with the Microsoft Win CE, where during this time also they added a multimedia extension. Okay, actually DEC is the company, is also the company. We started to develop the ARM processor 6, ARM version 6 architecture and produce a strong ARM. This is the one that really boosts the ARM processor during this time, ADEC. Where currently, where in the beginning it start to run at 233 megahertz, where later Intel bought strong arm from the DEC and then call the name to X scales. But it is it is a failed movement by the Intel. And later on, Marvel at 2006 bought the X scale from the Intel. Okay, this is showing the trend. Okay, the trend of the processor. This is the instruction, million instruction per second which can be executed here until now, or maybe after 20 years, the instruction that we execute in a second growing. Okay, we have three kind of the ARM architecture, which we call it as Cortex A, Cortex R, and Cortex M. Cortex A, which is the highest performance, okay, the highest performance, and it is focused to optimize for rich operating system. So if you are doing heavy processing, then you need to use the Cortex A. And then we have a Cortex R, which is the fast response, okay, optimized for the high performance, real time application. Okay, for example, if you are going to use for example, in the ABS system for the automobile, okay, you need that kind of real-time application. And then we have Cortex M, which considered as a smallest and the lowest power. Okay, it is optimized for discrete processing and microcontroller. Actually, this is the one that we have in our lab, and we are going to during your lab you are going to use a Cortex M. Okay, this is the version that we can have. For example, in ARM 7 started at Cortex M0 until Cortex A15. So this is for the application embedded. Actually, this is more onto the learning process. So what we have actually in our lab also, Cortex M0. Okay, in Cortex M0, it is an ultra low gate count, so the number of the transistor is less, so it's about 20K. Ultra low power consumption, which require 3 microwatt for every megahertz. 32-bit processor, it is standard for all the ARM processor. And actually, it is based on ARM version 6 ARM architecture. Cortex M0. Actually, it's quite similar with other processors. The only thing is the number of the count and the number the low power for each processor. Okay, and then we have Cortex M1, which are the first ARM processor designed for specifically for implementation in FPGA. Okay, this one we are not going to discuss into further discussion. This is just for your own knowledge. And then we have M3 also, also from the FPGA to ASIC, and only this part, this Cortex use the ARM version 7, which have the pipeline, three stage of pipeline. And then we have Cortex M4 for embedded processor digital signal processing, which have the floating point unit, and it actually based on the ARM version 7 EM architecture. And then we have Cortex M in more advanced architecture of the Cortex M version. Okay, so this is uh, the trend in the M Cortex processor from the first M0 until M7, which have a lot of battery and going to the right it's become more complex and more performance, more high performance. So if you look here in the beginning, it's just the lower cost and lower area small one still consider lower cost and lower, and then it started to use as a digital signal control application. Okay, this is the basic diagram of the ARM processor. Later on, we are going to discuss into detail each of it. If you look here, the Cortex M3 and 4, which have the pipeline. Pipeline also we are going to discuss it later on. And then also we have the floating point unit. Okay, this is only for version M4 and so on.